Okay, guys, we're going to look at this question, which most of you, in fact, I think all of you struggled with in the classwork that I set earlier on in the week. It does surprise me that most of you struggled with it because we got some really smart students in the class, and this isn't a particularly difficult question. However, I think the reason you struggled with it is the way it's been presented to you. It's literally the wording of the question, and also the format, the way it's basically, it's not a typical exam style question that you're used to. However, the content is relatively straightforward. So what we're going to look at is we're going to look at the question, and it contains a lab, and they've got a sample of sodium sulfate. So the sodium sulfate, to check the purity, because they're suggesting it's 99.5% pure. To check the purity, the lab are doing a bit of donkey work to try and analyse the sodium sulfate. But what you should be latching onto is that you've got barium chloride and sodium sulfate. As soon as you see barium and sulfate in the same question, you should be thinking about a precipitate of barium sulfate. They really like to ask about barium sulfate precipitates, certainly with questions involving analysis, because they can draw out a lot of information about you as a chemist by asking you a relatively simple question, and it's just basically seeing who is who is switched on. So we're going to focus on this part C, and then we're also going to look at D when we consider our answer to C will basically give us the answer to D. So let's have a quick look. What they're suggesting is that the student, or the technician, dissolved 3.627 grams of the sample. Now the sample was sodium sulfate. It's really simple. All you got to do is you've got to use your knowledge and understanding of group 2. That basically barium sulfate will form a precipitate when you've got the barium chloride and the sodium sulfate mixed together. Your starting point is this: it's 3.627 grams of sodium sulfate. So sodium sulfate, we need to work out the mass. So it's 3.627 grams. We need to work out the MR, of the sodium sulfate. So sodium sulfate is, so let's go here. It's going to be it's 23 for the sodium, 32.1 and 4 lots of oxygen, so 4 lots of 16. But don't forget that the sodium, we need 2 of them, so it's 2 of them, 4 of them, and just the 1. So by the time we've looked at that, what we've got is an MR for sodium sulfate of 142.1. So if we do our mass over MR to give us the number of moles, we would end up with a number of moles of 0.0255, roughly. Okay, so what we've looked at is we've got the number of moles of the sodium sulfate. So it's the mass that they've given us divided by the MR of the sodium sulfate to give us the number of moles. Now because it's a 1 to 1 ratio, and the number of moles of sodium sulfate is also the number of moles of barium sulfate. So if we just multiply that by the MR of the barium sulfate, so the barium sulfate, the MR for the barium sulfate is going to be, so we just basically zip back here, so we know what the sulfate is going to be. It's 4 lots of 16 at 32.1, and barium is 137.3. So you add the 137.3, 64 and 32.1. So by the time you've done that, you come out with 233.4 for the MR. Now we know it's 0.0255 moles of the barium sulfate. So if we just multiply those together, we should get the mass of the barium sulfate that we're expecting. So if we, let's have a look, 233.4 multiplied by 0.0255. So this is given as an answer of 5.9517 grams. That's what we're expecting to see. However, what they've asked you to consider is that the sample is 99.5% pure. So at any point in this calculation, you could do it here, you could do it down here, you could do it here. We're just going to multiply that by 0.995 to get our 99.5% pure sample. So if I just take this calculation that we've just done, if I multiply the answer that we've got by 0.995, which is 99.5%, that should come out with, should give us 5.922. So that's basically the grams that we were expecting to precipitate. So the number of the mass of barium sulfate that we would precipitate from 3.627 grams of sodium sulfate when the sodium sulfate is 99.5% pure. I don't think it's particularly difficult. To answer the next question, which is, do you think the supplier's claims were justified? Well, we just go back now. The supplier suggested it was 99.5% pure. Their 3.627 grams of the sodium sulfate only yielded 5.644. We've calculated that we were expecting 5.922. So 5.6 is too far off 5.9. So basically, you could argue, do you think the supplier's claims are justified? No, they're not justified, because if it was 99.5% pure, you would have got 5.922 grams. Instead, you got 5.644, so it wasn't 99.5% pure. It was actually less pure, so it was below 99.5%.